Hello, this is a video about endothermic and exothermic chemical reactions. Here are the two questions we're going to be looking at in today's video. Number one, what is the difference between endothermic and exothermic reactions? Question two, what is the reason why some reactions are endothermic and other reactions are exothermic? Here we go. First, let's start with two examples. There's a link to a YouTube video if you want to watch two examples, chemical reactions, but I'll just tell you about them here. In reaction 1, barium hydroxide and ammonium chloride were mixed, and the temperature in the beaker decreased. In reaction 2, we mixed calcium carbonate and sulfuric acid, and the temperature in the beaker increased. By the end of this video, you should be able to answer, were these reactions endothermic or exothermic? Did the reactants gain energy or lose energy? And where did the energy go to, or where did the energy come from? We'll come back to these questions at the end of the video. So, first big idea, what is the difference between endothermic and exothermic chemical reactions? An endothermic reaction takes in energy. Endothermic reactions absorb energy from their environment so that the temperature of the environment decreases. These reactions take thermal energy, heat, and convert it into chemical energy. The opposite process is an exothermic reaction. Exo means send out or outside. So exothermic reactions release energy to the environment so that the temperature of the environment increases. That means that chemical energy is converted into thermal energy. So both of these types of reactions describe how energy flows in chemical reactions, either being absorbed or released. We use these words system and environment, so let's take a minute to look at what those two words mean. The system in chemistry is the things that are actually reacting, the reactants and products, the atoms and molecules that are part of the chemical reaction. Everything else is part of the environment. That's the beaker, that's you, that's the air, that's maybe water if these things are reacting in solution. Everything that is not itself part of the reaction is part of the environment. If you're trying to measure the temperature, you can't really measure the temperature of the system, but we can measure the temperature of the environment, right? We can put a thermometer in the beaker where the reaction is happening. So now let's look at how energy can flow between the system and the environment. One possibility is that the system loses energy to the environment, right? The reaction releases energy so that the temperature of the environment will increase. That's an exothermic reaction. Energy is leaving the system, it's going outside the system, exothermic. Another possibility is that the system takes energy from the environment. That would look like this. If the reaction absorbs energy from the environment, the temperature of the environment will decrease, and that is an endothermic reaction. So those are the two possibilities here. Now that we know what endothermic and exothermic reactions are, let's look at why they happen. Why are some reactions endothermic and other reactions exothermic? This all has to do with chemical energy. We've learned already that positive and negative charges repel, positive and negative charges attract. Because of that positive-negative attraction and like charge repulsion, substances have chemical energy. And the chemical energy changes during a chemical reaction when chemical bonds are being formed or being broken. Remember that the definition of a chemical change is that chemical bonds are formed and or broken. These changes in bonds either absorb energy or release energy. To help you think about this, we can imagine two magnets, or take two magnets, right? And two magnets are attracted to each other. When they snap together, they release some sound energy. So forming a new chemical bond releases energy. But the magnets are stuck together, so to pull them apart, you would have to add energy, right? They don't just fall apart on their own. You have to give energy to the magnets to pull them apart. Chemical bonds work in a similar way. So let's look at this energy diagram. This is a graph where we have progress of the reaction on the x-axis and potential energy, chemical energy, on the y-axis. In this reaction, carbon and oxygen, O2, are going to combine in a synthesis reaction to form carbon dioxide. you'll see that carbon and oxygen, okay. I don't have a way to edit this. All right, wave my hand. Here we go, starting again. Since the first thing we need to do to make this reaction happen is to break the original chemical bonds, we need to separate those two oxygen atoms. Breaking chemical bonds requires energy to be added. So step one in this reaction, we're going to absorb energy and break the original bonds in the chemicals, in the reactants. Once we have those bonds separated, we can now make new bonds to form the products. So step two will form new bonds and release energy. You'll see in this graph that step two is a bigger change than step one, right? More energy was formed from making new bonds than was released to break the original bonds. I said that backwards. More energy was released when the new bonds were formed than was absorbed to break the original bonds. That means that overall, in this reaction, energy was released. This is an exothermic reaction because energy was released to the environment gets hot, so energy is a product in this reaction. Let's look at another example to see an endothermic reaction. In this reaction, we're separating water molecules to form hydrogen and oxygen. Again, the process is the same. The first thing that needs to happen is we need to break the bonds in the reactants. That requires absorbing energy. So step one, absorb energy to break the bonds in the reactants. Step two, make new bonds, and making new bonds releases energy. In this reaction, more energy was absorbed in step one than was released in step two. So overall, this reaction absorbs energy. This is an endothermic reaction because energy is absorbed by the system. The environment will get cold, and energy is a reactant because you need it at the beginning to make the reaction happen. So this is how energy diagrams work for endothermic and exothermic reactions. Let's come back to these two examples from the beginning. In reaction one, we said that was an endothermic reaction. The temperature in the beaker decreased because the reactants absorbed energy. The reactants gained energy, and that energy came from the environment, which is why the environment gets cold. That's an endothermic reaction. Reaction two is the opposite. This is an exothermic reaction in which the reactants lost energy, and that extra energy went to the environment, which is why the temperature in the beaker increased. Thank you very much for watching.